Financial Modeling, Topic 6, Computing Portfolio Value at Risk, or VaR, Random Walk Simulations, Macros, and At-Risk Simulations by Lou Gaddis. References for this material include Financial Modeling, 4th edition by Simon Benenga. Chapters 24 covers generating random numbers, 25, an introduction to Monte Carlo methods and simulation, 26, simulating stock prices, 28, value at risk or VaR, and 38 is subroutines, i.e. macros. Also, here's a link here if you're looking for information about the at-risk software which we will be using. So, Topic 6, Section 1, computing the value at risk or VaR of a portfolio using a formula. Later, we'll then do that using a Monte Carlo simulation. So, value at risk, usually just referred to as VaR, is the amount of money you should expect to lose given a confidence interval over a specified time period. In other words, it's kind of like a worst case loss. For example, if someone were to tell you that the 95% confidence interval 1 year value at risk is $27,900. Again, one interpretation is that is a worst case scenarios. And what that means is that you're 95% confident that losses will not exceed that VaR amount, $27,900 loss. However, there's a 5% probability of losing more than $27,900 if you're told your VaR is that amount. One way of thinking about that is if you look at a normal distribution bell curve, what we're talking about is a distribution of losses. So the 5% worst case loss is the 95% confidence interval VaR. So let's talk about the formula for calculating the VaR. So if a portfolio returns are normally distributed with an expected return of mu and a standard deviation of sigma, the X% confidence interval VaR is going to be minus today's portfolio value times the annualized mean plus minus Z of X times the annualized standard deviation. So let's do an example and see what this formula actually means. Say I have a portfolio that's worth $100,000 today, and I want to know the 95% confidence interval 1 year VaR. In other words, what is that 5% worst case loss that I could expect? Well, my X in this case is 95%. And how I calculate it is I put my $100,000 as my V. I assume my portfolio maybe has a mean return of 5% and a standard deviation of 20%. Now, calculation in this formula is calculating the Z of X. So, Z of X, where X is 0.95, turns out to be the value of 1.65, or if I do a little more precise, 1.645. 45. I'll plug that formula in, so I have $100,000 times 5%. That's the expected return of that portfolio, so I'm expecting to make $5,000 on that portfolio. However, assuming a normal distribution, we know from a normal distribution table that critical Z value for 95% confidence interval one-tailed test is negative 1.645 standard deviations. In other words, there is a 5% chance of having a minus 1.645 standard deviation return away from the expected value. So I expect to make $5,000, 5% of $100,000, but there's a 5% chance that I can have a 1.654 standard deviation change or value less than the expected. So that is my $27,900 VaR. Now the negative sign in front simply reflects that VaRs are losses, but they're always quoted as a positive number. So $27,900, if I don't put a negative sign in front of it, is a negative number, but by putting the negative sign in front of it, it changes it to a positive number, and we just quote the VaR as $27,900, even though it is a loss. So that's how you calculate VaR. You have the expected return, but could have a Z standard deviation change, where Z depends on the confidence interval. Let's talk about confidence intervals a little bit. Most VaRs are either 95% confidence interval or 99% confidence interval, and sometimes 90% confidence interval. The only difference in the formula we just did is if we're doing a 95% confidence interval, I use 1.645 standard deviations. That's associated with a normal distribution. If it's 99%, I use a 2.326 standard deviation change. That's my z of x. And if it's a 90%, it's 1.28 standard deviations. And again, these z values can come from any standard normal distribution table that provides z's and probabilities. So that's where I get my z. It's generally going to be 128, 1.645, or 2.326 standard deviations. If I want to do a daily VaR, say I want the VaR over t number of days, well, I would just use the daily mean times t days. And I'd use the daily standard deviation times the square root of t days. So if I wanted to know the 5-day VaR, I would just take the daily mean times 5 days and the daily standard deviation times the square root of 5. And remember, from a previous topic, that's because standard deviations are scaled across time using the square root rule. Generally, however, I don't generally have this information to calculate my VaR. Most times in finance, you're quoted annualized returns or mean returns as an annualized number and standard deviations as an annualized number. So if you start with that data, annualized means and annualized standard deviations, and I want a 5-day VaR, I'll take the annualized mean divided by 252, which is the number of trading days in a year, and take the standard deviation and divide by the square root of 252. That'll convert the annual mean and annual volatility into daily numbers. And then again, I can just then multiply times t days and the square root of t days. So let's go to the spreadsheet and calculate VaR for this portfolio. So I'm going to go to my spreadsheet. And look, I already have some named ranges set up. I have V, you can look up here in the top left corner. UA is the annualized mean or average. 20% is the annualized standard deviation. I called it SA. So UA is the annualized mean and the SA is the annualized standard deviation. I have T days. There's T up there. I have the confidence interval of X is 95%. And I did a calculation here, norm S inverse of X. And what that's going to calculate is that critical Z for a 95% confidence interval. So I am going to calculate the VaR using that formula we just reviewed. I'm going to take minus my V. Let me make that a little bit bigger for you. I'm going to take minus my portfolio value today times open the annualized mean, 5%, divided by 252. That gives me a daily mean, times, looks like we're doing a 1-year VaR here, so 252 days, T, minus Z of X, my Z there, so I'll click on my Z, times the annualized volatility, U, SA, divided by the square root of 252, that turns it into a daily standard deviation. So I'll take 252 to the 1/2 power. That is right here, that is the daily standard deviation. I'll then multiply that number times the square root of t to turn that into the term of the VaR. I'll close that. And we get 27,897, which is really close to that 27,900 we calculated when we were rounding this to 1.645. So there it is. That's our formula VaR. In this topic, we calculated the formula VaR of a portfolio, or calculate the VaR of a portfolio using a formula. Next topic, we'll simulate portfolio values using a random walk model.